So our panel is presenting on statistics. We're going to talk about statistics in one of these two ways, but not both. Statistics, it's a branch of mathematics. It's about deriving formulas, developing theorems, about the analysis, the collection, the organization of information. That's the part we won't be talking about. We'll be talking about the application side, which is the second part. The methods that are used to describe, organize, analyze, and, important step, interpret information. So, this is one of my students' data files. Actually, it's one tab out of 5. What does this mean? Anybody? And that's why we need statistics. For statistics, it helps you take that set of numbers, even some of those numbers that actually represent categories, they're just represented using a number. Take that and make sense out of it. Apply it to a research question. Help you answer a research question. So you start off with a theory, a well-supported theory, or maybe even a novel one. That theory generates hypotheses, testable predictions. A good theory. Can somebody give me an example of a good theory, a well-established theory? Looking at you, Dr. Benson. I'm going to go with evolution. That sounds like one most people have heard of, yes? So, what's the one prediction evolution makes? Yes, I'm picking on you again, Dr. Benson. That's the only prediction it makes. That's it. There are lots of predictions. A theory does not make one prediction. It makes a set of predictions. A set of predictions that can be tested. Any one study isn't going to test the entire theory. It tests one particular prediction, or maybe a couple of predictions. If that theory is valid, those predictions will be accurate. How will you know they're accurate? The predictions it generates statistically play out. In other words, the observations match the predictions. To know if the observations match the predictions, you have to test those observations. You have to go out there and make observations. When you make those observations, you get data files like I showed you. Those data files then have to be applied to the hypothesis. You have to use the information that's in that numeric format to decide if, in fact, that hypothesis was supported, which in turn supports the theory, or that hypothesis was refuted, which in turn does what to the theory. Thank you for giving me the psychology answer. It falsifies at least a part, or at least casts doubt on that theory, which is what drives science forward. If a prediction of a theory is wrong, that theory needs updating. If enough predictions from a theory don't pan out, turn out to be wrong, you replace it with a better theory. And that's how science moves forward. Replacing bad theories with better theories. Not necessarily perfect theories, but better theories. So, what can you do with statistics? You can identify two types. You can look at relationships that exist between variables, or you can see if there are differences between groups. For example, for admission to Marian, what information do students have to provide? On application to Marian, what do students have to say about themselves when they apply? It's not a trick question. Their name. Is their name related to college performance? If somebody's named Bob, are they more likely to succeed at college? That is something you could study with statistics. And the answer is no, Bob doesn't matter. But there are things that do matter. There are things that are related to college performance, like SAT scores, ACT scores, college GPA or high school GPAs. Those are related to the variables we care about when they get here, which is how they do at college. Their college GPA, their likelihood for graduation. And statistically, we can identify what factors matter and what factors don't matter. So, when we have an application sent to a student, they can fill out the information we know is related to college success and can skip over the stuff that's not related to college success. Now, group differences. Group differences are about identifying whether 2 samples, or 3 samples, or 4 samples, or 5, or however many samples you collect, whether those represent distinctive groups. They are different from each other, or, in fact, those groups are not different from each other. For instance, popular area of group differences research, gender. What differences are there between males and females in terms of things like spatial skills, in terms of things like language skills? So you'd use statistics to compare one group to another group to decide if, in fact, those groups are different or are not different. You can use statistics descriptively, hence the name descriptive statistics. This is something you see very commonly. When you see percentages, when you see averages, when you see ranges, the difference between the highest and the lowest scores, the highest and the lowest values. Those are all meant to describe an entire set. So for instance, when we get information on the incoming class, like their average high school GPA, or their average SAT scores, we're looking at a descriptive statistic. We're looking at a statistic that describes the whole group, but the big advantage, you don't have to look at every single high school GPA from every single student who was admitted to Marian. You get one average. It organizes the information, gives you one number to describe the group. Inferential statistics are then used to draw conclusions. Inferential statistics are built upon the difference between samples and populations. Population is the entire group of interest. A sample is far more practical, though. In general, populations are much too large to actually measure any characteristic of the entire population. So instead, you use a sample. You take a smaller group, a reasonable sized group, something that's actually possible to collect, but you have to know, does that group reflect real differences in the population, or is it possible that that group only reflects what's known as sampling error? Sampling error exists because you don't have all the information. If you don't have all the information, there will be sampling error. So anytime you're using a sample from a population, sampling error will be an issue. Inferential statistics allow you to measure the relative effect of sampling error so that you can then draw a conclusion beyond just sampling error about a population. Now, to kind of conclude my part, why are a sociologist, a biologist, a physician, and a psychologist, not a single one of us a mathematician? Why are we talking about statistics? Because of the application of statistics. Statistics are used in a wide variety of disciplines. We're a sample. See, using the terms back again. A sampling of the disciplines that use statistics. But we all the disciplines that use statistics use it in a similar way to be able to sort what's meaningful evidence from what's not, what doesn't matter. So a lot of us receive training in statistics, in the application of statistics, outside of statistics programs. We receive that training within sociology, biology, medical school, PhD programs across the board in a lot of different disciplines. So, you have resources at Marian. If you're interested in doing research, no matter what your discipline may be, there are people here, for examples up here, that can help you use statistics effectively. But here's a key, and I think my co-presenters will try to drive this point home. Talk to us early. Don't wait till you've done the study and say, here's my stuff, make sense out of it. Talk to us early, because part of the use of statistics is helping you design a study that will be a study that can be analyzed in a meaningful way and getting more out of that information.
Thank you. Yeah, it works. I'm going to use this because while I am not typically known as much of a mover, I am indeed a shaker. So, nothing? Oh, okay, there you go. All right. This is a cartoon that is a little bit small in the bottom part, but I'll read it to you. It says, if she loves you more each and every day, by linear regression, she hated you before you met. This is a really good cartoon to illustrate exactly what I'm going to talk about, and that's the purpose and limitation of statistics. Even if you use a very valid test and you do it the right way, if your assumptions going into this are not correct, you can end up with some very misleading conclusions at the end. And that's actually what we're going to talk about, that statistics are not the end-all and the be-all. It requires, as Jeff said, some upfront organization and some post-hoc organization as well. Jeff said, had a quote in his slides, and I know he did because I saw it yesterday, and this was changed from the original, so thanks for that. But he said, statistics provide the methods to describe, organize, analyze, and interpret scientific information. That's true. I agree with that. I would agree, though, even more with a slight amendment, and that is if the amendment was like this. Maybe I overemphasized the font a little bit, but statistics help to do those things. They are not the sole arbiter of those things. And the reason for that slight addition, that slight amendment is that if you why isn't it moving here? Well, let's try this. There we go. And what we're seeing here is that if you do something incorrectly ahead of applying the statistical test, like, for example, you don't adjust for possible confounders between your experimental groups, or after the statistical test has been performed, if you misinterpret the results or don't quite understand what the numbers mean, even in the setting of actually doing the right statistical test, even in the setting of doing the right statistical test, you will end up with invalid or unimportant results. Can you see that at all? Bad color choice, huh? Okay. So bottom line is, it's not just the statistics that you have to concern yourself with. Case in point, you want to answer a question with statistics. Is there a difference between two groups? So I would like to have you take a look at this study result. This is more or less just some descriptive statistics about a study. There was a study performed, a pneumonia mortality study, completely bogus, completely made up. If you saw results like this, where the people who got the therapy positive portion of the study cohorts, the people who got the therapy had a 10% mortality rate and a 90% survival rate. And the people who did not get the therapy had a 90% mortality rate and a 10% survival rate. Wow, that's very impressive. If you show that piece of information to most people, it would be very easy for you to sell your snake oil. Very easy, okay? No one's going to argue with that information. You just present it straight face, and you're going to sell your product for sure. The one thing about this that is very misleading is that they fail to let you know that the people who got the therapy looked like this. Like this, you know, healthy, young, vibrant, had no other confounding medical conditions, ate good things, apparently spent so much money on good food that they couldn't afford clothes, but nonetheless, these were very healthy, vibrant people. The people who did not get the therapy ended up looking mostly like this. So they didn't randomize their population. The people who got the therapy had lots of other reasons to survive the pneumonia in addition to the therapy. So even though the numbers look very impressive, messing up the confounders leads to very erroneous information. Okay, so that's point number one, and that's setting up the study. That's what Jeff was saying. Talk to somebody early about setting up a research study to make sure when you generate your data, it will yield something about which you can make valid conclusions. The second part of this is afterwards. And I chose these two problems with statistics because I see them with some frequency. And this is a matter of not truth, but importance. How important are your results? Consider two drug studies for the same disease. Okay, study A is conducted as follows. It's a study between drug B and a placebo. So study A uses drug B and compares it to a placebo. As it turns out, it demonstrates a benefit at a p-value of less than 0.05. So you say, okay, that's statistically significant. Good for us. A second study, study C, claims that the difference between drug D and a placebo has a p-value of less than 0.000, et cetera, 1. Okay, so it has a much, much smaller p-value. They're treating the same disease. They both show efficacy. They are both statistically significant. The question I have, though, and the question your patients or your readers for whatever study that you're conducting will want to know, which one's better? Which one is more powerful? And apparently, I'm supposed to ask the man, I forgot your name, but the fellow in the blue shirt. I'm supposed to ask you these questions. Apparently, that's the way this works. So which drug is more powerful? It depends. That was one of the answers over here. What they call the psychology answer, is that what you said? Okay. So yeah, that's the psychology answer, and it does indeed depend. Because what information I gave you doesn't allow you to make that assessment, okay? What I gave you was that the smaller p-value only indicates that it's a much, much smaller chance of that difference being due to chance alone. It doesn't say anything about how effective the medication is, only that both of them were effective, but the second drug, drug D, was the one that had less chance of demonstrating an effect by chance alone. Okay? The importance, or in my line of work, the clinical relevance of the difference is related to what the actual difference between the performance of one drug versus the other actually is. And I know that sounds a little bit convoluted. Let me try to clear that up in my last slide. If drug B decreases symptoms by 90%, remember that's the one with the p-value of less than 0.05, but if it decreases symptoms by 90% and drug D only decreases symptoms by 1%, both of them are statistically significant, but only drug B's effect is clinically relevant. It's the difference between, is there a difference, and do I actually care if there is? Okay, so that's the difference that we're trying to get at here. Does this come up in the popular media? Absolutely. You've seen the commercial. Okay. Don't let a 1% difference in reliability cost you twice as much. This is exactly the point that this fella is trying to make here. If we showed a, again, make-believe graph of the comparison between, I think he's advertising for Sprint now. It's not a very good commercial if I don't remember what he's advertising for. He used to be the Verizon guy. That's what sticks in my mind. Let's say that there is a difference between Sprint and Verizon, a statistically significant difference where Sprint is 98% reliable and Verizon's 99% reliable. You can see by the bell curves here that there is the mean differences and that the variance around those mean differences is relatively small. So the chances are that 1% difference is real. It is statistically significantly different one from the other. But the bottom line is, as this gentleman's saying, so what? From a practical standpoint, well, it's statistically significantly different. I just don't care. And that's the point that they're trying to make.
Thank you. Can you hear me? So, how many of you guys have at least some stats knowledge? So the rest of you, are you totally confused yet? Scared? Scared? Okay, that's okay. All right, one of the things that Jeff brought up is that a lot of us tend to just collect data and see what shakes out. That's not how we want to do a design. There are many flaws to this approach for doing a study. John has brought up that there are limitations to statistics, whether or not the results are actually relevant, but also statistics just analyzes data. Like, it just analyzes numbers. It can't tell you whether or not a study was done appropriately. It can't tell you whether or not data was collected in an ethical manner, in a controlled manner. That has to be interpreted by people, by you. There's that human element to doing studies. And all of your statistical tests, whatever tests you want to use, Bessie's going to talk about a lot of the different tests that are typically used, and even of the 5 that she's going to talk about, there are variations on those. It's incredible. It's complex. And we're not here to scare you. We're here to tell you that we're here to help. But that it is important to start that process early. So one of the things that you want to do when you're designing a test, or think about designing a test, is do your test subjects actually represent the population that you're trying to make inferences about? They should. If you're doing a study on one of your classes at Marian University, realize that that is not extrapolatable to the entire higher education, format in the United States. It's not going to work. It might be extrapolatable more so to small private institutions, but really it applies to Marian students. Are the test subjects independent? That's one of the things that are one of the assumptions that most of our statistical tests make. Are the test subjects independent of one another, or are they dependent? Well, guess what? If you're taking one single class and doing a study on one single class, they're not independent of one another. So there are limitations to that. And then, has your design accounted for any biological, psychological, or sociological influences? Have you controlled for these influences? Have you equalized them? Like John brought up, the one group having, very healthy, vibrant people, and the other group having, deathbed people. So you want to try to make sure that those are distributed equally. And then, if there are any sorts of issues, try to correct for that. Also, it's important to determine up front, are you going to do a mensurative study or a manipulative study? So a mensurative study, you're just collecting data, like Jeff mentioned, data on applicants to Marian University, right? You're not manipulating their gender. Their gender is what their gender is, right? So you're just collecting that information versus a manipulative study where maybe you want to try out a new case study in your class. So you have, one of your sections doing that case study and another section not doing that case study and seeing how they perform on some assessment. And then whether or not you're collecting qualitative data or quantitative data. Qualitative data is a little bit trickier to analyze depending on how you collect it. There are limitations to, there's just far fewer tests for qualitative data versus quantitative data. So if you don't think about how you're going to design your experiment up front, you run the risk of not being able to analyze it at all. There may not be a statistical test for the design that you created. That happens a lot. You may not be actually answering the question that you're posing. You may be answering some other question that was not of interest to you because you've collected the wrong data, or you've used the wrong survey instrument, or you're just interpreting it differently. So something that everybody's familiar with is our student evaluations, right? So student evaluations do not assess student learning, right? Everybody realizes this, right? So it's the student's perception of what the class was like. So making sure that we define these things appropriately. Another thing, not being able to confirm the effects because we have some confounding variable that we did not account for. So maybe you're in the middle of a study and, I don't know, you get sick and now all of a sudden your student evaluations are terrible because you weren't there for your students. Well, that's a confounding variable that was thrown in too, regardless of whether or not this case study was effective. And then again, not being able to extrapolate to the population of interest. So I'm going to run through this fairly quickly. The point of this is not to memorize like what all these steps are. The point is to notice where actually collecting the data happens. Okay? So the first step is specify your question, then convert your question into a set of hypotheses. This will start out as a set of research hypotheses, and then it's best practice to just convert that into a set of statistical hypotheses. Determine which variables are relevant to the question and which ones you have to control for. Determine what kind of variable each one is. Is it nominal? Is it interval? Is it ratio? Do you know the words that are coming out of my mouth? Okay. If you don't know, you need stats help. Okay. Design an experiment that controls or randomizes the confounding variables. And based on the number of variables, the kinds of variables, the expected fit to the parametric assumptions, and the hypotheses to be tested, you will choose the best statistical test. If possible, do a power analysis. Has any of you heard that before? Okay, so power analysis up front can help you determine how many test subjects you need in order to potentially find an effect. And then step number 8, do the study. Step number 8. This is not step number 1. It's step number 8. Okay? So after we thought about what actually we're collecting and all of that. All right. After you've collected the data, then we examine the data to see if the assumptions of the statistical test that we chose have been met. And then apply the statistical test, interpret the results, and communicate the results of your study utilizing graphs or tables in your presentation or paper. Any questions for designing? I know it was really fast, crash course. It was, yes. Right. Okay. So maybe so designing it really depends on what the question is that you're asking. But qualitative data is data that doesn't have numerical values. So if you're asking, let's say you're going to kind of mix psychology and art, okay? And in one of your art sections, you always wear a red turtleneck or some variation of red and orange. And in another section, you always use like blues and purples. And then you ask them at the end of the semester, what color do they prefer to paint in, to see if your wardrobe choice influences their choice of preference in color palette. So then you would measure the number of individuals who respond with red or blue or those kinds of hues, because that's their answer. Their answer is not measurable. It's a word. It's purple. It's green. It's blue. Does that make sense? All right, anything else? I know there's a lot, so I'm going to hand it over to Bessie. Which one do you want? No?
I'm Greek. Our normal level of voice is loud anyways. I don't think I need a mic. So if you guys can't hear me, let me know. I doubt. Okay. So you've done all of this. You've collected all your data. You've done your power analysis. And now you don't know which tests to run, right? So if you're anything like my students, you get in front of SPSS, you get super excited, you throw in your variables, and then you stick your hand up and you say, SPSS isn't working. It keeps giving me these error messages, these big warnings. And I walk over and I say, well, what variables are you using? You haven't followed the rules with your variables. So on top of all of these rules that my co-presenters have just given you, now there's more rules with your variables. So at the baseline, there's 5 common tests, right, that we've all heard of. These are your t-test, your ANOVA, your chi-square, your correlation, and your regression, okay? Chi-square and regression is going to give you the same results. It's measuring relationships, right? But it all depends on your variables. Chi-square uses nominal level variables, what color is your hair, and regression uses continuous variables. If I give you the number 5,000, right? Everybody can picture this number, 5,000. Close your eyes. Beautiful number. I put a $ sign in front of that. What does that mean to you? I just put this in your bank account. You just made $5,000, right? Happy? Yes? Good. Take that same number, that $5,000, put a slash, deaths per year. Does it still have the same meaning? No, right? It now evokes a different feeling. This is what stats and numbers do, right? They tell a story. So this is why we are all up here, right? And we can all talk about stats. It's because we're telling a story that is specific to our disciplines, okay? So I'll go through these 5 tests really quickly. But before we get to any tests, ask yourself 3 questions. Your data, your samples, your purpose, okay? What does your data look like? What's the level of measurement that was used for your data, okay? Every variable has a level of measurement. This is going to be nominal, ordinal, interval, ratio. Anybody know the differences? Good. Dr. Marola, you want to tell me the differences? Okay. So when you're looking at your data, you want to ask yourself, if it's nominal, it's categorical, or what we know as non-parametric. It comes in nice categories. Some examples would be, what is your sex? What is your hair color? How are these values presented? These are known as summary values. You're going to usually see them as percentages, proportions, or as frequencies, plain numbers. Pretty straightforward. You see them in a table format. Okay? Some tests that we use for any type of these data, nominal data, are your test for proportion, your differences of 2 proportions, and your chi-square test for independence. This is different from your chi-square test of your fit for goodness test, okay? So I'm not going to get into all of that. I don't want to scare you guys. The second type of data level of measurement is interval ratio. This is back to that 5,000. It's a continuous flow, right? questions that you might be asking yourself is, what is the temperature outside? Well, it's the holidays, right? So many New Year's resolutions is I'm going to start to lose weight. So another question is, how much do I weigh, right? Those zero values have absolute meaning, right? And the last one is, what is your age? So these tests are a little bit more advanced. You can look for a mean. You can look for differences between two means. You can look for any kind of paired sample tests and regression analysis, correlation analysis, okay? So this is a little bit more advanced testing versus your nominal. So many of you guys are going to say, well, what happened to your ordinal data? Your ordinal data is a little bit tricky. It can kind of go in between both of them. It could be nominal or it could be in the interval level with tests. It just depends on the circumstances. So ordinal level variables are your Likert scales, right? If you add more than one Likert scale and it becomes an additive measure, you've just tricked SPSS into thinking it's an interval level scale, okay? Because there's absolute difference between the categories. So you can run a little bit more advanced testing on that. But it doesn't matter about the test, it's how you interpret these numbers. The second question you're going to ask yourself is, how many samples do you have? Do you have just one sample? Did I just give you guys all a survey, look at it, done, right? I never have to see the survey or these people again? Or am I going to come back to you guys and do a repeated measure survey? Ask you guys the same questions in 10 minutes, a before and an after. You guys are still the one sample, right? Or am I going to have two or more samples? Okay? Am I going to have the same survey and keep asking different people? Before, after, right? More groups. These will require different testing. Okay? Which now leads you to your third question. What's your purpose? So is it a hypothesized value? Are you taking your value and are you looking at the bell curve, right? That theoretical that Jeff was talking about? Are you going to compare it to the theoretical? If you are, you're going to test for proportions, you're going to test for means, or you're going to look at the difference between two means. Are you comparing two statistics? Are you doing a before and an after, and you're looking at the difference between the two? If you are, these tests will be your difference between two means or your differences between two proportions. More independent samples. Or the last one, are you looking for relationships? Did one have an effect on the other, right? These are your chi-square for independence or your regression analysis. Right? Everybody wants to know about relationships. We live in a society where everybody loves each other, right? So everybody wants to know about relationships. But are your variables the right level of measurement? Okay? Do you have nominal level variables where you're looking at people's eye color? Okay? And you're trying to run a regression analysis on that. Like Kim said, those are colors. They're going to evoke more qualitative findings. Okay? They're not like that number 5,000 where it's more continuous, where you can run a regression. You can look at your scatter plot, like Jeff's illustration looked at, right? With the, if you love me more than you must have hated me at the beginning, right? That type of relationship. And at the end of the day, here's the flow chart that all statisticians kind of follow. Okay? I know this looks a little scary. I can go through all these tests, but it's here to show you that it all depends on the level of measurement. Your test is specific to the level of measurement. Okay? Your t-test, if you want to run a t-test, your independent variable has to be categorical, 2 categories. Your dependent variable has to be continuous. Okay? Well, now you say, well, my independent variable has 3 or more categories. Can I still run a t-test? No. Kim, what are we going to run? An ANOVA, right? Well, now you have, two continuous variables. Are you going to run a chi-square? No, you're going to run a correlation or a regression. But it all kind of goes back to your purpose. It all goes back to your limitations. It all goes back. Once you get to this stage, that means you've satisfied all of these stages. And you probably successfully passed most of our classes in statistics to get to this stage. Okay? So, those are the commonly used statistical tests. Those are the ones that we use. Those are the ones that you read a lot about in journal articles, without touching on ANCOVAs and all the other ones. If you guys are interested, I know a lot of other universities have research departments and research teams where you can bring your research to these teams and they will help you along with it. I don't know if we become the research team by doing this, but here is our information, and please feel free to reach out to any one of us early on, hopefully, because once you get to choosing the right test stage, you kind of have to go back and make sure that you didn't pass up on your surveys.